Okay, here we go. Let me help you with the first assignment of algebra. The first question, what is the next term? We have a sequence, right? We have a sequence that says 4, 7, 10, and on, okay? To predict, we have to observe, we have to look for the pattern. So let's compare the three terms we have. We can see from the first term to the second, it goes up by 3, right? And from the second to the third, it goes up by 3. So we can assume that the pattern is for each term, it will goes up by 3. Therefore, we can predict based on the pattern. We say for the next term, it will goes up by 3 from 10. So it will likely be 13, right? 4, 7, 7 to 10, 10 to 13. Yes. So the answer should be 13. And next, in the Fibonacci sequence, 0, 1, 1, 2, 3, 5, 8, 13, 12, 21. What is the next term? So the Fibonacci sequence is famous for its special pattern. So we have the first and the second term as 0 and 1. Then starting from the third, it's going to be the sum of the previous two terms. So the third will be the sum of 0 and 1, and that's going to be it's going to be a 1. It's going to be a 1. And the next term is going to be the sum of 1 and 1. It's going to be a 2. And the next term is going to be the sum of 1 and 2, and that's going to be a 3. And the next is going to be sum of 2 and 3, and it's going to be a 5. So you can see it's the sum of the previous two terms. And we can predict based on this one is going to be 8, and the next one is going to be 13, and the next one is going to be 8 plus 13 is 21, and the next is going to be 13 plus 21, that's going to be a 34. It's going to be a 34. So the next term is going to be 34. So this is just a training on using the pattern to make predictions about a sequence. Let's go on. What is the next term? -3, -7, -11. So still we have 3 terms, and we need to look for the pattern so that we can make predictions. Let's compare the first two. What happened between -3 and -7? So here you need to be careful. Some students might say, okay, it add 4. You say add 4. Well, that is not correct. That's not correct. From -3 to -7, it actually subtract 4. So if you do -3 add 4, that will give you a positive 1. It's -3 subtract 4 can give you a -7. All right, so you should be careful here. And from -7 to -11, what happens is subtract 4 again. So -7, if we plus 4, it will give you -3. It's -7 subtract 4 can give you -11. So be careful, be careful. And we can tell the pattern is subtract 4. And then we can predict for the next. I predict this pattern will happen again. So it's going to be -11 subtract 4 again. And what is that? What is that? For some students, it's going to be easy, but for some, this is confusing. What is -11 subtract 4? So there are two methods you can solve this. First, imagine you have a thermometer of 0, and your -11 is 11 below 0, right? And subtract 4 means further goes down by 4. Further goes down by 4. And this point is going to be 11 and 4, 15 away down below from 0. So this new result is 15 down below 0. So it's going to be a negative 15. Or you can use the calculator. Use the calculator to find out. All right, so this should be a negative 15. And this is our answer. This is our answer. Let's go on. Let's go on here. What will be the sixth term in the sequence? 10, 9, 8. Okay, prediction, right? Prediction again. So we have, this is our first term, second term, third term, right? And we are needing for the fourth, fifth, and sixth. We need them. Okay, still it's making prediction. Let's observe for the pattern. From 10 to 9, subtract 1, right? And from 9 to 8, subtract 1. Then what's next? Subtract 1. It's going to be 7. Then subtract 1. It's going to be 6. And then subtract 1. It's going to be 5. It's going to be 5. So here, we are just making consecutive predictions. We are using the pattern for 3 times, and then you can find out the sixth term. What is a common difference in this sequence? Common difference. See, common difference is another fancy term for interpreting the pattern. We are still trying to find out the pattern. So let's compare from 5 to 10. Add 5, right? And from 10 to 15, add 5. Okay. So we can say, we predict this is a pattern. So the pattern is add 5 each time. Therefore, between the two consecutive terms, between 5 and 10, the difference is 5. Between 10 and 15, the difference is 5. And we can predict between 15 and the next term, the difference is 5. Therefore, we say the common difference is 5. The common difference is 5. Okay, and there might be some confusion. Is some students may say, okay, from 5 to 10, I think the pattern is doubles. I think the pattern is double. You might think so, yeah, it seems to be okay. But remember, the pattern should apply to every term in this sequence. If you assume the pattern is to double, then it should apply to the next. So that means the double should apply also to this one here. But from 10 to 15, it's not doubling, right? It's not doubling. Therefore, if a pattern doesn't apply to every term, then it's not the pattern. It's not the pattern, okay? So when you are looking for the pattern, your pattern should apply to every term. Okay, let's go on. What is the common difference in this sequence? 4, 2, 0. Okay, let's look for the pattern. 4 to 2. 4 to 2 is subtract by 2, right? This pattern also applies to the next term. So 2 to 0, subtract by 2. Therefore, we can say this pattern looks like to be subtract 2 for every term afterwards. For every term afterwards. And the common difference is it 2 or negative 2? It should be negative 2 because from first to 2, it's decreasing by 2. So the common difference here is negative 2 because every term is going down from the previous. So it's negative 2. some students might pick positive 2. If it is positive 2, your term should look like 0, 2, 4, 6, like that. And this is a positive 2. This is a positive 2. But the original term, the original sequence, the common difference is negative 2. It's negative 2. Therefore, our answer is negative 2. Negative 2. Again, some students, they might say, okay, I think the pattern is 4 times 0.5. Well, it might be true 4 times 0.5 is 2. But again, this pattern doesn't work for the next term. 2 times 0.5 is 1. It's not 0. That means that's not the pattern. That's not a pattern. Okay? So when you assume a pattern, you have to make sure it works with every term. If a sequence has a formula, the nth term equals -7 plus 6 times inside parentheses n subtract 1, then what is the fourth term? So now we have a formula. We have a formula. This is a big change. This is a big change. -7 plus 6 times n subtract 1. What is the fourth term? So to do this, we have to understand when we use n, a letter like this, what does it mean? So this means the n is changing. It can be first, second, third, or fourth, or whatever. It can be changing. So when you need to look for the fourth term, you need to do is just plug the value of 4 to every place where there's an n. So we're going to use 4 to replace n. So if we do that, we kind of have this, right? That means the fourth term equals to -7 plus 6 times parentheses. This is a 4, right? We use 4 for to replace n every time there's an n. So 4 subtract 1. And you can see the fourth term equals to this. And we just need to, do the calculation here. So I hope you still remember the PEMDAS. The PEMDAS. That's the order of operation, right? So first, let's deal with the things inside the parentheses. The things inside the parentheses. The things inside parentheses is 3. 4 subtract 1 is 3. So inside the parentheses, it's a 3. It's a 3, right? It's a 3. And we have 6 times 3. 6 times 3. And then we should do exponential. We don't have exponential. Then we do multiplication and division. So here we have 1 multiplication. So this is going to be 6 times 3 is 18. Therefore, we are going to have -7 plus 18. That's multiplication, and we don't have division. And lastly, we go to addition and subtraction. And that's going to be -7 plus 18. That's 11. That's 11. So therefore, the answer should be 11. The answer should be 11. Next. If A1 is -7, that means the first term is a -7. AN is, okay, we have a formula again. AN equals to AN subtract 1 plus 12. What does that mean? What does that mean? Okay, let's start with the question. So we are looking for A4. If we need A4, we are kind of using 4 to replace n. So we should replace n for 4 every time there's an n. So therefore, A4 equals A time the 4 subtract 1 is A3, right? A3 plus 12. So, okay, we know that the fourth term is the third term plus 12. Then we need the third term. How do we find out the third term? The third term, if we look for the third term, that means n is 3. And that's equals to a3 subtract 1 is a2. That's going to be a2. And then plus 12. So here we see, I see what's going on, right? Then what's a2? a2, here n is 2, right? a2 equals 2 subtract 1 is a1, then plus 12. a1 plus 12. Okay, so a2 is a1 plus 12. a3 is a2 plus 12. a4 is a3 plus 12. So every term it's increasing by 12. And what's a1? a1 is negative 7. a1 is negative 7. This is our a1. And our a2 is going to be negative 7 plus 12. And a3 is negative 7 plus 12 plus 12. That's going to be our a3. And a4 is going to be negative 7 plus 12 plus 12 and then plus 12 again. That's going to be our a4. So let's do the calculation. Oh yes, and let's pause for a moment and hit the subscribe button. Everyone, let's hit the subscribe button. Let's subscribe. Okay, pause a moment, hit the subscribe. Not in the video, but hit the subscribe button in your browser. Okay, so let's do the subscription and let's go back to our sequence. Negative 7, right? That's a1. Then plus 12, that's a2. And then plus 12 again, that's a3. And then plus 12 again, that's a4. So our fourth term should be 29. Therefore, the fourth term is 29. And that is our answer. Let's go on. Find the formula for this sequence, 5, 8, 11, 14. So we have 5, 8, 11, 14. So to find the formula, let's first look for the pattern. What is a pattern? From first to second, what difference? Plus 3, right? Plus 3. And from second to third, 8 to 11, plus 3, right? And from 11 to 14, plus 3. So we can say, okay, the pattern is every term is 3 more than previous term. And so we say, as we just did, this positive 3, this is our common difference. Common difference is 3. Common difference 3. And we know each term is 3 more than the previous term. But what is the initial, the first term? The first term is 5, right? The first term is 5. That means a2 is a1 plus 3. And a3 is a1 plus 3 plus 3 again. a4 is a1 plus 3 plus 3 plus 3, right? a5 is a1 plus 3 plus 3 plus 3 plus 3. So each term is 3 more from the previous. Then what is the formula? How do we find out the formula? Say, if you observe, you'll see here the a1 never changed. The a1 is always there. The a1 is always there. And what changing is the number of the term and how many times do we add up the 3. The second term we add up 3 for once. The 3, okay, let me rewrite this part. So 3 plus 3, I will rewrite this as 2 times 3 because I add up 3 by 2 times. 3 plus 3 plus 3, I rewrite as 3 times 3. So this is 3 times 3. And 4, 3 add up, that's gonna be 4 times 3, 4 times 3. And this one, I rewrite this as 1 times 3. Okay, here you might see, okay, this is just 3 by the times. As you can see the connection here, you can see the connection here. For A2, this 1 times 3. For A3, it's 2 times 3. For A4, it's 3 times 3. For A5, it's 4 times 3. And then we can predict for, let's say, for A6, it's going to be A1 plus 6 subtract 1, it's 5 times 3. Okay, so it's always 1 less than the number of the term. And we can predict maybe for A100, it should be A1 plus 99 times 3. So here we find the secret. It's always 1 less than the number of the term. Therefore, if we say, okay, for a very, very large of number, let's say AN, we can predict the A1 is still there. But this part is going to be 1 less than N. 1 less than N, it's N subtract 1. And then times 3, times 3. So we find out the formula. Let me write it down here. AN equals to A1 plus 1 less than N times 3. That's a formula. And look at our options. Oh yes, our A1 we know it's 5. Our A1 we know it's 5, right? Our A1 is 5. So let's just use 5. Let's just use 5 here. So the nth term equals to 5 plus n subtract 1 times 3. 5 plus n subtract 1 times 3, I think, yeah, that's the answer. That's the answer. So this is how we do the formula of the sequence. And you can see the general formula is just, let's rewrite this. The general formula is AN equals to A1 plus n subtract 1 times 3. The 3 is our common difference. The 3 is our common difference. So it's actually times the common difference. We use a letter D here. So this is a general formula for all sequence, for all arithmetic sequence. For all arithmetic sequence, AN equals A1 plus n subtract 1 times the common difference. That's the general formula. And we're going to use this general formula to do the last question because I don't want to repeat the whole process again. So we find out the general formula based on this question. Let's use this with the last question. So the last question we have 100 plus 99, sorry, it's not plus, it's just different terms. 199, 98, 97, right? And what's the pattern? And you can see here, it's every time it's a subtract 1. So the term is subtract 1, subtract 1, subtract 1. So the common difference is subtract 1. And the first term, A1, is 100. See here, the first term is 100. And the common difference, the common difference is subtract 1. Okay, once we have this, let's use our general formula. We can say, for this sequence, AN equals A1. Our A1 is 100 plus n subtract 1, 1 less than n. Then times D common difference is -1 times -1 times -1. And we need to further simplify this. So let's unpack the parentheses. So this is a -1 times a parenthesis. Then it will be this part, this part, this part. It will equals to -1 times n. It's going to be -n, then -1 times -1. So -1 multiplied by the two numbers inside. So -1 times n is -n. The -1 times -1 is going to be a positive one. It's going to be a positive one. So here it's going to be a positive one. And therefore, we have an equals 100 subtract n plus 1. 100 plus 1 is 100. Therefore, 101. So we have 101 subtract n. And that's our general formula. That's our formula for this sequence. Based on the general formula, we plugged in the value of A1 and common difference into this general formula, and then we simplify that. We got the formula for this sequence, and that is 101 subtract n. Let's look at our... the option doesn't even ask us to do the simplification. So you can see here, 100 -1 times, it's going to be negative n subtract 1. So the question doesn't actually ask us to do the last step. So, okay, we didn't even do the last step, okay? But I want you to see that if we simplify, it's going to look like this. But here we can stop here, and we can see this is the formula. This is formula. Basically, we just plugged in A1 and the common difference into the general formula, And this is how we deal with sequences. And one last thing. Let's pause for a moment and let's hit subscribe. Everyone, subscribe. Hit the subscribe button and don't forget, subscribe. Do it now.